Hey everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we are going to finish up Chapter 10, Lesson number 2. We'll start on page 458. Page 458. We're going to talk about the partial consecutive series property. All right, what in the world is that? Well, that's a good question, right? So let's start with that. Let's figure out what that thing is. What does it mean partial? Well, here's what's going on. This time, for the first time we've seen this now, the bottom, the lower bound, is being bound by something, okay? It's not 1, okay? It's being bound by the number 4. So what do we do when this lower bound is 4? Well, here's what that means. All we need are the numbers between 4 and 8 because there's the lower bound and there's the upper bound. Now look, see, in essence, we don't even need these numbers 1 through 3. We can get rid of those because we're not using them. Now, really the only way that we can do this is by using this little formula right here. If you look down here, we are going to have to take... So this is the original. This is what we started off with. But we are going to have to take the whole. Notice I'm starting with 1 here. I equals 1. So this is all of them. Okay, this is all of these numbers. Okay, and I am subtracting the ones I'm not using. Which ones am I not using? I'm not using 1 through 3. I'm not using 1 through 3. I need to get rid of these. So what do? I solve for all of them, and then I subtract the 3 that I don't need. That's the way this needs to be done. Okay? So let's go ahead. Let's try this. We won't try it with this one. We'll try it with this one down here. Okay? So here's the example. So our lower bound on this one is 5 and our upper bound is 9. So all we really need is we need 5 through 9. In other words, 1 through 4, those are the ones we're going to get rid of. Okay? And I'll just kind of I'll put a little cross through those, but so you can still see 1 through 4 because we're going to need that. So if we go ahead and build our sigma notation here, we're going to say that this equals the whole. Remember, we start with the whole. So 9 is our upper bound. I equals 1 is our lower bound. And then I. Okay? Remember, this one is the whole. So we're taking the whole minus the part. So minus the part. Another sigma. And what's the part? 1 through 4. So it's going to be I equals 1. And we're going to go through 4. So that's going to be the upper bound. Is right there. Okay, and so now we're going to want to go ahead and just solve it out. I'm on the next page 459 on the example, if you're wondering where I am. Okay, so let's go ahead and solve it out. What do we need here? Well, we need the formula. What's the formula? Do you remember the formula? That was in the last lesson. All right, I'll write the formula right up here. So the formula is n times n plus 1 divided by 2. Okay, so we're going to take that formula and do it for that one, and then we're going to subtract, and then we're going to do the formula for this one. Okay, so what's the n? The n here is 9, so we're going to do 9 times 9 plus 1 divided by 2 minus, and this one is 4, because that's the upper bound, 4 times 4 plus 1 divided by 2. All right, so we have 9 plus 1, that's 10. 9 times 10 is 90, divided by 2 gives you 45. Minus 4 plus 1 is 5. 4 times 5 is 20, divided by 2 is 10. All right, so 45 minus 10 gives us 35. So the answer to this one would be 35. All right, so let's go over that concept again really quick here. So we don't need 1 through 3 on this one. How do we know which ones we don't need? It's based on the lower bound. The lower bound starts at 4, so we don't need anything over here. On this one, on our problem here, our lower bound started at 5. So we didn't need anything over here 1 through 4. So we take the whole and we subtract what we don't need. This is what we're getting rid of. And then our leftover is the answer, 35. All right, look down there at the next section on page 459. This is the distributive property for a series. So how are we going to distribute in a series? All right, so here's what it looks like right here in green, in the green circle. So we have our, this is kind of like our main sigma notation. There is our upper bound. There's our lower bound. This is our I, which is our index. And so now here, what do we have? Look what we have. We have a, what is that? That's a letter, but what is it? That's a variable, okay? So whatever I is, plus or minus, whichever it is, whatever B is, okay? What does that look like? How do we solve that? Well, the way that we solve it would basically be we do the sigma notation with this one, that's this, and then we do the sigma notation with this one, and that's this. And then we add or subtract them, okay? So basically we just kind of distribute it through, or we distribute the sigma through. So that gets the sigma, and that gets the sigma. There it is there, and there it is there, okay? All right, so let's try one of those. Let's go ahead and try to distribute this thing. Whoa, we have a 3, so we're going to have to distribute it here, and distribute it here. But that's fine. Just take it piece by piece. And let's build our new sigma notation right down here. So we have the sigma notation with 10I equals 1. And then we have 2I squared minus sigma notation 10I equals 1, and then the 3I. And then we have a plus, sigma notation, 10I equals 1. See, I'm just copying this right here, okay? It's just distributing. And then an 8 right there. Now, this one's interesting. I like this one because this one's going to give us some practice on all 3 of our formulas. This one is the one with squares. This one is just the regular one, and this one is the one with just the constant, okay? So let's go back over them. This was from last lesson, but it's actually part of lesson 2, but we didn't do it. So this one's going to be n times n plus 1 times 2n plus 1. Okay, that's the squares. Divided by 6 minus, whatever we get there, minus, this one's just the regular one, so this one's just the n times n plus 1 divided by 2, plus this one, and this one is the one with just a constant. It doesn't have the I there, and so that one is just the Cn. Okay, so let's go ahead and just put our information in there. So everywhere that there's an n, we are going to put the upper bound of 10. So I just erased all the n's, and now I'm going to go back and put the upper bound of 10 in all of those places. The only other variable we have is the c right here, and that is the constant. And so that would be right here, which is 8. 8 times 10. And now what you want to do is you just want to solve all that out, and once we solve it out, we will hopefully get an answer. All right, so this is going to be a big one. We're going to need our calculators for this one. This one's going to be 10 times 11 times 21 divided by 6. So just go to your calculator on that, and we'll do 10 times 11 times 21 divided by 6 equals 385. So that's 385 minus All right, so on this one, we have 10 times 11 divided by 2. 10 times 11 is 110, divided by 2 is 55, so minus 55. And then this one is going to be 80, so then it's plus 80. All right, going back up to this, I've got all my numbers right now, but I did not write down the multipliers. These right here, this 2i, we have to factor out, basically, and factor this out. These are multipliers. So once we're done, we're going to multiply that times 2, and we're going to multiply this one times 3. Okay? And then that will give us our total. So come back to your calculator, and you want to do 2 times 385 equals 770. Minus 3 times 55 equals 165, and the 80 did not have a multiplier. The 80 was, the 8 was the multiplier there. So now I just come back and go ahead and subtract it out and add, and I would get 770 minus 165 plus 80 equals 685. 685 is my answer. And it's right there on page 459, and we did get the correct answer. So, all right. Don't forget those multipliers, okay? I probably should have, it probably would have been better for me to just write them outside every time instead of just waiting until the end, because I think those are easy to forget if you don't write them down as you go. So don't forget about those multipliers there in front of the i's. All right, let's try one more. This is on page 460. Page 460. Okay, so let's do this. What we're going to do is we're going to solve out what we can solve first. In other words, this right here has something that we can solve. So we're going to distribute that right there. So we're going to get 2i, so 5 plus 2i minus 2. Now look, we can combine like terms. We have a 5 and a minus 2, and so we're going to get, and you can write it on either side, but I'll just write a 3 plus 2i. It doesn't matter in that case. It doesn't, since it's a plus sign, we can move it to either side that we wanted to. All right, now what we want to do is we want to distribute that sigma to both of them. So we're going to get the sigma with the 4 on top, and then the I equals 1, and that's going to be a 3, plus the sigma with the 4 on top with the I equals 1, and 2i right there. Now notice this one also has a multiplier right there, so be careful of that. And then we're just going to solve these, okay? And so this one is just the simple one. This is the Cn, so that's going to be 4 times 3 plus, and this one is not a square, so it's just the n times n plus 1 over 2. We'll just plug into that. We'll plug in our n is 4. And I'm going to pull that multiplier of 2 out there so that you can see that sitting out there. Okay, just go ahead and solve it. We're going to get 12 plus, and this is going to be 5. 20 divided by 2 is 10, times 2 is back to 20. So this would be 32 would be our answer on that one. Okay, so that's really kind of just algebra right there in a way. You're distributing, and then you're working your formulas, and then you get an answer. Okay, not too complicated, but it's not too easy either. I think once you get the concept, it becomes a little bit easier, but the main concept is the hard part. Try some of those. Practice those. Use your formulas. Use your math skills. Distribute. Do the things that you know how to do. All right? Well, that's all I have for you in this lesson. I hope you have a good one. We'll see you later. Bye-bye.